Hello everybody, we're going to be looking at working with Python libraries in this video. We're going to start with one of the most fundamental of their libraries, and it's called the Matplot library, which is indicated right up here. And the point of all this is really to allow you some tools to work with data that you might have. One of the most elegant things about working with Python and why it's so heavily used in data analytics is basically the fact that there's so many pieces that they've added to these libraries, these standard libraries that they have, and then some of the extended libraries that are made by third parties or other people that allow you to do things in a pretty rapid fashion with simple sets of data. So in the previous couple of units, we learned how to kind of work with some GUI components, so you have those coming into the mix here. And some of the GUI components that are coming in here are really generated by those libraries, so we don't have to really worry about, for example, like you see this graph here, we don't have to worry about creating the objects that make that, the squares and the bars and the lines and even the text that's running vertically up the side here. We don't have to manually create out any of those things. The libraries actually do that for us. It's just really a matter of providing the proper parameters so that it can adjust what it normally creates to that format. So let's just take a really quick look at an example here, and I think that will be a good way to work. Now, I am pulling from our Python book, and this is in chapter 3. It says page 117 down here. I don't know how accurate that is relative to the actual book, but that's where I am. So it is in chapter 3, and although my side menu here it shows chapter 6, I'm in chapter 3, toolbox 3.2, which is just at the end of the chapter, right before you go into the chapter summary and the exercises. All right, so the example that they're giving us here is we're in Fairbanks, Alaska, and it says you're considering whether to accept a position up there, and you get worried about how warm it gets up there. Now, interestingly, I have a friend from high school who was actually stationed up there in the military right after high school, and my uncle also served up there. And what a lot of people don't know is because it's in the interior of Alaska, away from the large bodies of water, it gives it a continental climate. So yes, it does get wickedly cold in the winter, but conversely, in the summertime, it actually gets to be pretty warm up there in the mainland, and it's quite a dramatic swing. So you can see the average temperatures here. So it's sometimes not even unusual in June, July, or August for the temperatures up in Fairbanks to be, believe it or not, higher than they are here in Milwaukee. Anyhow, you can quickly take a look at the data that's provided. So these are average temperatures for those months, and you can see that they're transferred over to this chart. Now, if you had to create this manually, you could do it. You could also take this data and drop it into Excel and use the charting feature in Excel to create a graph like this. The reason that we're using Python is to learn how we can take data from, basically raw sources without having a tool like Excel and still create visuals that are meaningful and frankly look pretty good without a lot of effort. And that's what these libraries bring to us, is that ability to kind of rapidly create good-looking content without a lot of work. Now, if any of you have also taken let's say other forms of programming, so something other than Python, so you've learned maybe GUI programming with Visual Basic or C# or perhaps Java, and in those languages they do also have similar tools to these where you can pull in libraries and work with them, although they're not quite as elegant and really take a lot of futzing to get them to work as nicely as they do in Python. So often in C# or Visual Basic or Java, what we end up doing is actually manually creating some of the GUI components, and then also kind of manually creating some of the output elements just to make it look the way you want. And I think the one thing you'll see here, if you have that experience, is you don't have to really futz with it as much to get to the point of getting something that looks as nice as this. So the interesting thing is this the code that creates this is actually provided in your book. So if you go to your course shell, let me see if I can pull that up here. I think I have it open in the back. You'll notice that I have this little posting here, and there's a zip file attached. So if you download that, that's all the sample code. So all the in-chapter examples for the Python book are included in the zip file, organized by folder and then item. And the reason I provide that is so that you can see examples, and in many cases just kind of copy paste and adjust things to get your homework done. So I'm hoping that you take advantage of that. So let's get started on doing this first little example that they have here. So I would call this basically an activity, but it'll gear you up for doing the first assignment. All right, so let's go ahead and just try to follow these steps here. I do have Spider up and running, and I'm going to just kind of flip between Spider and this and just drop the code in and then show you how it works. All right, so let's begin by creating a new file, which I already have, and let's do a save as. So get into the habit of saving this stuff in folders that make sense, and I'm sure you guys already know that lesson, but I always feel that as an instructor, I'm always compelled to keep reminding people that that's important, because the one time you skip doing it is when it comes back to bite you. So I'm going to create a new folder here, and I guess I'm going to call it Unit 10. And I tend to not put spaces in my file names for many reasons, but there it is. So I'm going to go into that folder, and let's call this, what should we call this? Example. Graph example, how about that? I think that's a good name. And it probably won't like my dash, so let's go with an underscore. Or you could camel case it, I guess. All right, so here we are inside the file, and I'm going to grab that first line. So the first line in that code is pulling in the library. And this is, of course, a required step whenever you're working with libraries like this. And if you don't put it in, of course, the IDE will squawk at you because you don't have stuff that you're asking for. And you can see that the Pyplot, which is really the tool that we're using, is part of the Matplot library. So they have extensive sets. So this is just one little aspect of it. But this is one of the most common and popularly used, and I might argue maybe one of the more important ones, just because of its fundamental nature. All right, so here we got the import statement in. Next, we're going to go ahead and get some data that we want to show up. And I want to show you how beautifully simple this information is to add here. Because we're pulling from this library, we can just tell it, what the values are directly for each one of the bars. So this is not the example for the Fairbanks temperature. These are other values, as you'll see as we go. But notice how each one of the bars is receiving basically like an index number or an order number. So it basically knows what order to plot these on the screen. And then the second parameter there is the value, or let's say the relative height of that bar as we put it on the screen. We're calling a built-in method called bar, and guess what? It creates a bar chart. So that's kind of nice. Next thing that we're going to do is we are going to put in these values here. And the reason I'm going to just paste these into the IDE is I just want to do a comparison between the two different approaches. So this is not a replacement for what you're already seeing on the screen. I'm just showing you two different methods. Really, when you're putting in a bar chart, you really think about how bar charts work. Even in Excel, you usually need kind of like two sets of data in a sense to kind of set it all up, and those pieces of data are associated. So we could say that this index value here is associated to this value. And really, you can also set up this whole thing by putting in a couple of lists of the same dimensions one containing the index value and one containing the actual values that we're plotting. So you could use either approach. And so what I would do here in the example is I would say, or you can do it this way. And the funny thing is about this is I think that an inexperienced programmer might prefer the approach that I already had put on the screen. It's clear, it's simple, but you can see that it is repetitive, so it's not really the most efficient way to code, so it's processing that method several times over. In the secondary approach, we're really calling the method once, and it can process a whole list like this, and that list can get pretty huge. And remember, this is a two-dimensional list or two-dimensional array, if you want to think of it that way. The fascinating thing about it is that I think when you build up that experience and you get the numbers broken down into other lists, so let's say you're importing a list from somewhere else, you might already have it in that format. So that's why a lot of people will, with experience, I think will tend to move to this approach. For now, let's just leave that alone. Either one will work, is basically the point. So that's probably the hardest part. So if you are interested in maybe changing the output colors or the width of each thing, they have these examples here in the exercises, and guess what? Guess who's going to be doing those exercises? So you guys will get to play with that a little bit so you can actually adjust things. The next thing that we're going to do is we're going to put in some information to help it look a little nicer. So you don't want to just put data out there and not describe what you're showing to your user ever. That's the one nice thing about working with Excel is it kind of does it automatically. So if you provided in a spreadsheet program, a column header, and then you're using that data to build the chart, it kind of automatically grabs it. Sometimes you have to tweak those things, but here we're doing it kind of manually. So we are going to say that the x-axis is going to have labeled on it the month, and the y-axis is going to have the temperature. All right. And it's pretty simple. There's not anything more to add to it. It just operates. All right. And the next thing you need to do is just tell it to, okay, well, now you got the data. Now you got all the information you need. Let's put it on the screen. And there is the simple little command that does that. All right, I'm going to go ahead and be brave here and hit the play button, and let's see what happens. And you can see in the console window there, it did create these things. Now, one thing that you'll notice is, unlike our example in the book, all of it came in a different color, and that's kind of done by default. But you can see it accurately plotted the data relative to the values that we put in. It arranged it by index number. So maybe instead of index number, maybe here, if you want to change what you're doing, you could put in different values. So you could just do something to this effect. I'm assuming I did it all correctly. Let's run that again. And then you can see that fails because these are not allowed. All right, so then you will figure out how to put these in. But what did I forget to do? Of course, because these are strings. All right, so you would have to go through as strings and add in all the little quotes. So let's just do that really quick, just so you can see the result. And then you can move on to trying your homework or watching my next example, I guess. All right, so if we go ahead and plot that, then all of a sudden you see how the labels change. So these are very helpful. I might say that you might want to put little indicators in there, if you're going Fahrenheit, and you can just tweak it. Keep tweaking it until you get it the way you want. But you see how beautiful it is and how easy it is. Really all you're doing is feeding data into a structure, and it's just doing the work for you. All right, let's go on to the next example here. All right, they make a little note here. Yeah, and it says you can display it inside one of those notebooks. So if you happen to be using like the Jupyter notebook, for example, it'll give you instructions on how to do that. But we're creating just a simple little GUI program. Hey, and guess what? Here's the code right there. We could have just copied it in. But it's kind of nice to see it being built piece by piece. So that was a bar chart, and that's because we were using the bar mechanism there. For this next one, I'm not going to drop it into Spidery. You guys can kind of do this on your own if you want to try it. But they're trying to give you an example of how to do this, basically to create a line graph. All right, so different than a bar chart where each individual data set has an individual point, basically. Regardless of how wide that bar is, it's really hitting one point on the graph. And normally, like if we were to plot this on a regular Cartesian coordinate system, you wouldn't get a whole bar, you just get one spot on the graph, but the bar really makes it easier to see. So line graphs are kind of the same in that we're really hitting certain points in the coordinate system, but we're connecting those points with a line so we can see trends and changes as they kind of proceed. So this command here, or the method that they're using to put this in, is called plot. And with that, as with the bar thing, you can really provide the data in a couple of different ways. So you see here they went right directly to the secondary approach where they're feeding in two lists. So really a multi-dimensional list for both the high temperatures and the low temperatures. So in this case, because they're putting, they want to get the highs and lows on the same chart, you can do that right inside the same program. There's nothing that says that you can't. So you can plot multiple lines of data on the graph here. Now, right now, I'm looking at this, and just a little while ago, I was, looking at COVID-19 stats. So, I kind of had this like little thought in the back of my head how it might be kind of fun, I don't know if you would call that fun, to take the data that we're getting about all the things going on out there, and I'll show you a spot where you can get that data, and then plot it on a graph and see for yourself how the projections that you see out on the web are maybe created, and maybe you can even take it as far as creating your own if you want to take it that far. All right, but once again, we're using the plot, two arrays, and then it ends up creating two lines. The thing about the plot approach, the line graph, once again, is there's data points that will hit these spots. So if you kind of use the visual here, you'll see that like where the line takes a turn is right at that 3.0. And yes, we can plot two at the same time. You can also go in and change the color and the style of the lines, as it says here, and then you put in these special little parameters that control it. And that's just added to the end of the the method call as a third option. The other thing that they have provided with you here to make it a little bit more convenient, kind of showing you the dots there. And in some cases this might be helpful for you, and maybe other cases not. But here you can put in your color code, so they have the 8 basic computer colors there. You can also put in how you want the line to appear. So 1 dash is solid, 2 is dashed, a colon is dotted, and then a dash dot is alternate dashes and dots. You can plot that one. I'm not too much of a fan of that. Just depends on what you're doing. And then also the character types, or the dot that you're going to use to indicate what that point that you're plotting looks like, and those you can play with a little bit too. As far as I'm concerned, what it does automatically most of the time is just fine. This was just generated automatically, and yes, you might have to kind of extrapolate where the point is. So the one thing you might want to do is add a point, but you can see that it's useful just straight away without any enhancements. If you wanted for any reason to help people find their data points, you can also add a grid. And the command for that is very simple. You just say Pyplot grid on, and it just pops up. And then another thing that's interesting is the points that appear on the side of the graph, and that's something we didn't talk about in the previous example, but something that we've I guess run into when we were working with Excel as well, is Excel has a tendency, for example, if you put in a data set, to kind of maybe plot everything, maybe even beyond the ranges that you need, or maybe depending on your data set, it'll just plot just to the exact parameters. You see the automatic really kind of did a nice job. I mean, you got all the data points on there. There's no buffer around it. But in some cases, you might find it helpful to actually declare the ranges that you're working, just to maybe emphasize a point. So, for example, you were emphasizing the point that maybe in Arizona the average temperature is like 100 in June or whatever, but here it's only 60, just to show you that that's kind of a reasonable range. And really, if you think about it, most air temperatures tend to be in this range in this country. Maybe once in a while it gets a little below, maybe once in a while it gets a little above, and in the desert areas they might want to go up to 110 or 120. But you get the point. So what this next little collection of commands does is it says the X limit and the Y limits, and you set the upper and the lower bounds of those ranges. So in this case, we say we're starting at 0.5 instead of 1, and ending at 5.5, and then the lines kind of neatly sit in the middle. I don't know if that necessarily looks better, but it's just to demonstrate that you can. And you can put in half values or fractional values too. So, I mean, if I was to do that, to have a buffer, I guess I would prefer to start at 0. It's all arguable, it's just and subjective. The Y limit's the same way, and notice that here you can actually put negative numbers in, because like in this case it would be appropriate, because we do have values that on average are in the negative range. So I think that's pretty cool. Then once again, we can also label our X and our Y axis like we did before. They're throwing in an additional method here for title, and you can guess what that does. It puts a little thing in there. There's also the possibility to add a legend, and you see how simple it is, and you can label it to match up with your arrays. So like, for example, if you knew that the first, this one is the highs, this one is the lows, as they have it labeled here, then as you feed the data in, you can also create the legend in the corresponding order to display on your chart. Now, the next thing I think that's kind of interesting here is this little trick that you can do in the next section. It says you can also change the labels of the tick marks along the axis. So, in other words, these little spots here that automatically appear, those are the tick marks. And you can change the particular ones. So, for example, what they're saying is you can change in the aftermath. So you may have fed in index values for each one of those, and then this X-ticks allows you to switch these to read to correspond, and then you will actually have a combination of both appearing on the screen. And they give you a breakdown here of how you can actually change that. Now, the reason you might say to yourself, well, why not just hard code the label in there? Well, sometimes the numeric value that's put in that list is important, so we don't want to just go willy-nilly changing it to make a point. But you can see here that I can take all this code, and this isn't really smart because it's grabbing the line. All right, never mind. I'm not going to do that at all. You guys can type it in, but we'll just take it on faith that it works. It's really pretty simple, and you can get a lot done in a pretty simple little bit of effort. Some of the most key methods that are included in the Pyplot are shown here, and then it's just a matter of really kind of getting down and doing some of the work. So this will end this first video, and that should be enough to get some of these first exercises complete.